All right, everybody, this is 1.1. We're going to review adding, subtracting, and multiplying polynomials. All right, so first off, we need to make sure we remember what does it mean to have like terms. So like terms have to have the same variable and exponent. So if we look at this example, think about which of those are like terms. You might notice that there's parentheses around some of these terms. That's just for grouping for showing our polynomials. So here we have one polynomial. It has three terms. We call that a trinomial. And then we have another trinomial. And we're just going to add those together. Okay? And adding is combining like terms. Okay? So here we're going to combine like terms. They have to have the same variable and exponent. So it's best if you can always look for your highest exponent and then work your way down. That will make it so your answer is in standard form. Okay, so standard form. All right, so we have these two. Those are like terms. They both have the same variable and exponent. So we will add those together. We'll have 7 plus 3 will give us 10x to the third. Again, the exponents don't change when you combine like terms. It's only when you like multiply, like x times x would give us x squared. But x plus x would give you 2x. So let's maybe look at that really quick. Just so make sure we understand the difference. So this is like 1x plus 1x is 2x. But if we did x times x, that would be x squared. Because when we multiply variables, we add their exponents. All right, so then we go and find our next highest exponent. We've got our x squared. There's only one term with x squareds, so we'll just write that down. Okay, so we don't need to combine it with anything. Next, we'd want to find our x terms. Okay, so we've got 5, subtract 11 would give us negative 6x. And then we have our constant. That's the only one that has no variable. Okay, and that would be our answer. As you see, the highest exponent goes first, and then the next is the 2, and then we have a 1, and then we have our constant. So make sure you write your answers in that order. I'll skip B, but if you want to see it or check your work, I have it filled in on the notes. Okay? All right, next off is subtracting polynomials. Just remember that when we are subtracting polynomials, we need to distribute the negative 1. Okay? Otherwise, you might forget that you're subtracting. So here we'd have negative 4x squared, or to the fourth, and then we'd multiply that. Again, we can make that be a negative 1 if you prefer. Negative 1 times negative 9 will give us a positive 9. And we can distribute that negative 1 to the 7. We'll get negative 7. Okay, so this is all what we had before. We can just cross that out. And now we're just going to combine like terms. So start with your highest exponents. So we've got x to the fourths. So we've got, 6 subtract 4 will give us 2x to the fourth. Okay. Next, maybe we'll look for our x to the thirds, x cubed. We don't have those. So then we go to x squareds. So negative 2 plus 9 will give us plus 7. Again, you're welcome to use a calculator if you ever feel like that would be helpful when like negative 2 plus 9. Okay. And then we want to find our x terms. So we've got 3x, I think that's it, so plus 3x. And then we have our constant is minus 7, so minus 7. Okay, so that's subtracting polynomials. Again, if we're subtracting, it's best to distribute that negative or negative 1 before you start to combine like terms. Okay. Sometimes people ask, well, what about this parenthesis? Like, why do we need that? Well, really we don't. If we want to distribute, really parentheses are just if we have like maybe multiplication, like something in front of your parenthesis. Here, if we were to distribute a 1, it wouldn't change your answer, so you could really just drop that parenthesis, okay? But for the subtraction, we had to distribute that -1 before we could get rid of the parenthesis. All right, now multiplying. So when we multiply polynomials, so here you see here we have a binomial times a binomial, bi meaning 2 terms in each of these. When we did it last year, we used a box. So I'm going to continue doing that. If you learned a different way, that's just great. Okay. Sometimes I like to put the box underneath, but I understand that that might be a little too small for you. You could draw it separately. I'll even just do that now. Okay, so we'll do a separate box over here. And then we're going to put one of the binomials on top. Doesn't matter which one goes on top. And then the other will go on the side. And this is just like a multiplication table. We're just going to multiply the things that are outside to fill in the small boxes. So for example, 7 times 2 is 14. X times x is x squared. And then we'll go and do maybe our next box to the right. We'll do 7 times 3 is 21. And then x times y is just xy. And then maybe we'll go and do our next. We'll do -4 times 2 gives us -8. And then y times x is xy. When we order those, again, I'd probably recommend that you always do like alphabetically. So you have xy instead of yx. And there's nothing wrong with that, but when we get to the point where we want to combine like terms, it might be more confusing if they're not going the same direction. Okay? And then our last one, we've got -4 times 3 is -12, and then y times y is y squared. Okay? And then we'll just combine like terms. So there's only one box that has x squared, so we'll have 14x squared. Next we have our xy's, so 21 minus 8, and that will give us, I think, 13 xy, right? Okay, double check, got it. Okay, and then our y squared term is minus 12y squared. Okay. The rest of these are very similar. This one's a little different just because we have a trinomial and a binomial. So instead of doing a 2 by 2 box, we'd need to do a 3 by 2 box. Again, sometimes I like to just draw underneath. If you can write a box that's that small and fill in the stuff in there, then great. If not, maybe write it a little bigger. And then we're just going to multiply in. If it's helpful, you can always put a 1 in front of that x. So when we multiply, then you have like the coefficients you can multiply. So 1 times 4 is 4. X times x squared is x to the third. And then we'll do 1 times 9 is 9. And then we'll have x squared. Again, please pause and try these problems if you can. It will help you more than just like watching. Okay, this will be -1x. -20x squared, -45x, and then +5. Combine like terms. So here we've got our 4x to the third, our x squareds. That would give us -11x squared. Our x's would give us -46x, and then our constant 5. Okay. I think box is very helpful, especially when you get things as big as this. I think it helps keep it a little more organized. All right, last two like this. All right, so if we wanted to use a box, you could here. I feel like it probably would take extra time. I think we can just distribute like you would normally think about distributing, multiplying what's in front. But if you wanted to, you could do a 1 by 2 box and do the same thing that we just did. okay? So here we'd get negative 6x to the third, and then we can distribute that negative 2x squared to the negative 1, give us a positive 2x squared. Okay. And then if you remember, what do exponents do? I've had a handful of students in class so far wrote their answer as something like this: 4x squared plus 9, okay? And I think that's understandable just because we kind of think about distributing numbers, but we don't distribute exponents, okay? Exponents tell us how many times we multiply the base. So this is our base. This is our exponent. So it's telling us that we can write our base 2 times. All right, so why don't we do that? We can just get rid of this exponent and we can write it out. Okay, so now we can use a 2 by 2 box. All right, so here is our 2 by 2 box. And we have 2x minus 3 and 2x minus 3. And then we will just multiply in. And you'll get something like this. Okay? Oops, I missed my exponent. All right, and then we can just combine like terms, just like we did before. So we've got our x squared terms would give us 4x squared. Our x terms would give us, now watch out here, I had some people put as 0x, okay, but here we're taking something that's negative, negative 6, and making it more negative. So we should get negative 12, and then we've got plus 9. Okay? All right, and then last but not least, sometimes I'll try and have I'll do some screenshots of like your homework. The numbers will probably be different than yours, but the process is the same. So here are 2 examples that I just wanted to go over quickly. There are 3 polynomials here, and we're subtracting and adding, okay? So just a reminder that if there's not a number in front of your parenthesis, then it would be 1. If we distribute that, then it's not going to change. So really we could just get rid of that parenthesis. All right, next one is subtraction. So if we're subtracting, we need to distribute like a negative 1. So here we would end up getting plus 3x squared, and then negative times a negative will give us a positive 4x, and then a negative 4, okay? So once you distribute, we could just get rid of all of that, and we're just going to use what I wrote above. And then again, we have plus, so we're distributing a positive 1, which isn't going to affect that. So we could just get rid of that parenthesis. So now we're just combining all like terms. Maybe let's start with the highest. So here we've got x squared, here's an x squared, and here's an x squared. And then we're just going to add or subtract those coefficients. So negative 2 plus 3 plus 8. And you could do that in a calculator if you wanted to. It's not too bad. So negative 2 plus 3 would give us 1. And then 1 plus 8 would give us 9. So we'll have, maybe I'll put it in the box, 9 x squared. Okay. And then we'll go to our x's. We have 3 terms of x's. So we have negative 5 plus 4, so that's negative 1. And then negative 1 plus 6 would give us 5. So plus 5 x. Again, you can use your calculator for that if you wanted to. And then we have our constants. So negative 1 minus 4 minus 1. And that, again, use your calculator if you'd like. But that should give you negative 6. And you can just put that in. Again, when you do your homework, you can have multiple tries putting your answer in. If you don't get it by the 3rd try, then you can ask for a second or a similar question, and you can repeat that process lots of times if you need to. All right, last but not least, let's do a little box here. It looks a lot like one that we did, but it's a little different. So y plus 3 and y minus 3. So if we multiply that in, we'll get y squared, 3y, minus 3y, and negative 9. Okay, so we'll have our y squared term. Next we have our y's. So here we do have opposite signs. So we have 3 subtract 3 would give you 0y. If it's 0y, we don't write it, okay, because there's no y terms. There's 0 of them, right? And then we have our constant, so minus 9. And just push enter and you got it, okay? All right, well, if you have any questions, please stop by. I'd love to chat. We'll see ya.